composition is equal to the composition inside the reactor.
This is the main of CSTR, and in PFR here that
Ma'am, there is no axial mixing.
Axial mixing. There is no
axial mixing.
Only the
radial mixing.
So this is the theory, whatever behind this, you can see from the book also. And this is the flow diagram for CSTR followed by PFR here. This CSTR, here which we take as the in terms of CA naught or FA naught, that feed rate in moles per liter, feed in, then whatever at the CA here, then PFR and that exit. So if we see in the figure here, this is the experiment of CSTR and PFR in series here. So these are the, here if you see in the figure, these two are the reactors here, tanks, these two tanks. So here we are taking at the reaction is and component which we are taking, that is the NaOH and ethyl acetate here. So in this reaction, NaOH and ethyl acetate, one tank, that is the ethyl acetate, one tank containing the NaOH, and here we make the 0.1 normal of the ethyl acetate and 0.1 normal of the NaOH solutions here. And from here, that is the flow rate, same flow rate of this, both the reactors we are taking here. So in the experiments, we are taking near about in between 20 to 40 ml per or cc per minutes flow rate. So when we set the, this is the rotometer here, and in the second tank here, if you see this rotometer here. So this rotometer will control the flow rate from this tank to the this reactor and this second rotometer here. So the feed from both the tanks, that is here into the this components into the CSTR here, and then CSTR to this here if we see at the PFR here, and then at the exit here. So this is the your figure, the experiment which is available in the laboratory here. So but here we see that here this stirrer is here for mixing up these flow rates here, and here this from the exit means one concentrations that we can find out in figure here. If you see that is here, suppose we can take here X1 in the first reactor, that X1 is the XA1 is the conversion. Second we can take as the XA2 is the conversion, and this we are writing here, this CA1 means the exit stream. What is the here we are taking the concentration of NaOH, which we are considering that concentration of NaOH here, that is will be equal to this here. If you write the equation of the ethyl acetate and NaOH, that means stoichiometric reaction, if you write, it will give the product. हमें क्या मिलेगा?
Ma'am, C2H5ONA.
रिएक्शन क्या होगी? एथिल एसीटेट एंड NaOH, सोडियम एसीटेट, राइट? प्रोडक्ट क्या होगा आपका रिएक्शन?
Ma'am, CH3 CH2 CONA होगा, I think.
हाँ, यस. तो यहाँ पे हमारा जो
एक प्रोडक्ट CH3OH शायद.
1 mole of, if we are taking as the 1 mole of the NaOH, 1 mole of this, then in this reactions. Okay, so in this reaction we are taking that is the, if suppose we consider the reaction like A plus B is give as C plus R. Okay, so here A and B, if we are taking as the A and B, so the order of the reactions, how we will write here? This reaction here we are considering as the second order reaction. Okay,
yes.
if we means Ca concentrations here we are taking and Cb naught. So if any one component is very large concentration, then we can consider it as a first order reaction. When large excess of reactant, suppose B is used, then its concentration doesn't change appreciably. So that's why we can consider here minus Ra is equal to K Ca naught Cb naught, that we can write as K dash Ca. K dash means Cb concentration almost constant because it is very large. So now then it will be have like a first order reaction. So here we are considering as the second order reaction we are taking. So what are the solutions which we have to make here? That this 2 point here in this experiment we are taking as the, that is HCl we required for what? HCl we required here, HCl solutions, and in feed tank we are taking as the suppose 10 liter, because there are large tanks here, so we can take 10 liter, we can take 8 liter, it is means it is not fixed here. Point and ethyl acetate of the same concentration, sorry, same normality, suppose 0.1 normal and 0.1 normal, and this we also make as the 0.1 normal concentrations. And so this we can make here simply 0.1. How we can make this solution of the acetate, ethyl acetate?
क्या बोल रहे हैं आप?
How? First we have to prepare the point normal of NaOH. तो ये बना लेंगे हम लोग. Point I will discuss in the calculation part that how to make this. Yeah.
मैम
Then we fill up.
मतलब 0.1 ग्राम सॉल्यूट हम 1 लीटर सॉल्यूशन में ऐड करेंगे ना.
हाँ, नॉर्मेलिटी का मतलब है ना आपका that you takes in if the weight we have to find out that normality into equivalent weight into
per liter of solution.
V volume in ml, then we divide it by 1000, then it will give as liter. So that basically if that is here, it will be as a moles per liter.
अच्छा. 0.1 moles of
yeah.
solute. Okay.
This NaOH we will have when we make a solution of the 0.1 normal NaOH, we will do the standardization of this solution with the help of oxalic acid in the laboratory. कोई भी टाइट्रेशन हम सिंपल करते हैं, कि हमने NaOH सोल्यूशन बनाया तो हम उसको स्टैंडर्डाइज करते हैं. So against oxalic acid we standardize this. Okay. So these we prepare, then fill up here in the over tank. So we can take it is this quantity is not fixed, means 10 liter. You can take whatever you require, 8 liter, 5 liter as here, because we are taking here 10 liter, that large tanks. So to perform all the readings that we are taking initially at the 10 liters, but this is not the fix here, because this doesn't have means main thing is the normality. So this we fill up in the overhead tank here, using the valve and observing the rotameter, adjust here. So this adjust the flow rate with the help of the rotameter here. So here we are taking the in between the 20 to 45 cc per minute. That means suppose at one flow rate we can consider at 20, next we can consider at 25, and then 30, at least 3 different flow rates we can adjust here. So after attainment of the steady state, it will, when we start the experiment, it will take few minutes to come under the steady state. So when steady state is obtained, then we will start to take the sample. We will start to take the sample here. So we take small of the conical flask here, where we take the 25 ml of HCl solution in the conical flask here. And in this here, every sample here, suppose the 15 ml sample we take and then mix with this 25 ml. So whatever the basically the purpose of this, that whatever the this HCl will react with the sample solution, and sample solutions may have some unreacted component here, suppose unreacted NaOH, so that will react against this HCl. So unreacted, that will be react here. So whatever the, that we can find out whatever the components that have reacted here. So this procedure we follow here at the, suppose we can take at the end of the here exit from the CSTR, we can sample we can take, and we can take the sample from exit from the PFR here. So this is the procedure here, and then we do the titration, repeat the procedure for any here. What are the observations of the reactors here? So in the laboratory, that we have taken here the diameter of the reactor, which is in the laboratory, that diameter of the that CSTR, it 15 centimeter. Height of the reactor tank is 25 centimeter. So this is not, because we are not putting the height in calculations, height of the reactor. We are putting the, basically the volume of the reactor is measured by the whatever the height of mixture after steady state. Basically this important here. So height of mixture after steady state, that is 20 centimeters. Suppose for example we are taking some value here. So we will find out the volume of reactor, volume of CSTR reactor. Similarly, we can find out the volume of PFR. Here diameter of the reactor is 5 centimeter, length of the reactor is 60 centimeter, and volume of the reactor which we can calculate here. So here this table here we have shown here that case 1 for PFR, case 2 for CSTR. So this is the initial volume of HCl taken in conical. So we are taking every time 25 ml. We are taking in excess because some unreacted HCl that will be in the flask here. So this we take in excess. So initial volume of HCl taken in the conical flask, we have taken as the 25 ml. You can take suppose 30 ml or 20 ml here. Volume of sample taken from PFR, this CSTR volume which we are taking as 15 ml. So this we mix with this in the conical flask here, and then we titrate against the NaOH from the burette. So this readings of the burette NaOH giving, that means this much HCl, unreacted HCl is present in the this conical flask here. So these were we can take at the suppose initial at 5 minutes or initial value we can, after gaining the steady state, initial time we can start here the 5 minutes, 10 minutes, 15 minutes at t, or we can take at t is equal to 0. What is this here? T is equal to 5 minutes, t is equal to 10 minutes here. Then we will take 3-4 readings we can take, and then we can take and the average of these values here. Similarly, we find out for the this PFR here, and we can take the average of these values here. So now how to do the calculations here? This. So how we will do the calculation? First is the preparation of the NaOH. This we can prepare simply. How much weight of NaOH we required in 10 liter? So we can write here W, that is the weight of NaOH, is equal to N, equivalent weight of NaOH is equal to its molecular weight 40, volume that we are taking at a liter, so that is 10 liters, so that we can find out the weight of NaOH required to make 0.1 normal NaOH solutions. If the volume we are taking in ml, then we will divide by 1000. Then preparation of the ethyl acetate solution here. So here this value is coming as for 10 liter of, in 10 liter of the here 0.1 normal ethyl acetate, 98 ml of ethyl acetate plus 10 liter of water. This we will make here. So it comes basically that we can find out the means your molecular weight कितना होगा ethyl acetate का आपका CS3COO C2H5 CS3COO C2H5 molecular weight कितना हुआ आपका
88 ma'am.
88 gram. Okay. So molecular weight is 88 gram. Density of the ethyl acetate is 902 kilogram per meter cube. Density is 902 kilogram per meter cube. Then we will find out the, calculate the volume here. Volume required. So we will calculate here how much here V volume is equal to mass. So if we consider here this we are taking as the 88 ग्राम कितना हुआ आपका मॉलिक्यूलर वेट 88 है इसमें और हमें 10 लीटर में बनाना है तो 88 हम ये निकाल रहे हैं तो वॉल्यूम हमारा कितना हो जाएगा because the ethyl acetate which is the volume of the ethyl acetate which we are mixing here 98 ml of ethyl acetate here. So this will be 8.8 ग्राम होगा आपका 1 लीटर में. 8.8 ग्राम divided by the density 902 kilogram per meter cube. Then we will convert into gram per meter cube. Okay. So it comes as 0.0098 liter, that is 9.8 ml. So for 10 liter कितना हो जाएगा आपका 9.8 into multiplied by 10. So that we can measure from the measuring cylinder. So this way that they have written here 98 ml of ethyl acetate in 10 liter of water. Preparation of HCl solution here, that HCl which is available in the laboratory, it is not completely pure. इसका जब आप बोतल में जो फ्लास्क होती है उसमें आप देखेंगे तो उसमें लिखा रहता है उसका कि कितने परसेंट है इसमें. सम एक्वस सम वाटर इज देयर आल्सो इटसेल्फ. कितने परसेंट है वो दिया रहता है फ्लास्क में. So again the same way that we can find out here, density will be also given so that we can prepare this solution by the 0.1 normal HCl solution. So sample treatment after reaction, that 25 ml HCl in the conical flask plus this 15 ml sample we take from CSTR at the exit of the CSTR, or at the we can take at the PFR at the exit of the PFR here. So this sample 3/4 sample we take here, 25 ml HCl, 15 ml sample here. So this will be in the conical flask. Then it titrate against the NaOH in the burette here. Volume of CSTR we can find out this pi by 4 d square h here. This height at the steady state 20 we are taking, so this is approximately that we can write is centimeter cube here. This we are not converting here because this flow rate we are also taking into the same that is in cc per minute or 1 cc or ml per minute. So this we can write in centimeter cube here. So this is the residence time we can find out. V upon, in symbol you can change here because in your book it is given as V naught in Levin scale. So this you can change here, V upon V naught here. So residence time is tau for CSTR is equal to V upon V naught. V naught is the flow rate here. This we can find out here. So this volume, similarly we can find out the, this is clear? Hello?
Yes, ma'am.
Yes, ma'am.
How to calculate the volume of CSTR? Then we will calculate the volume of PFR. तो PFR के केस में हम लेंथ लेंगे. So the residence time in PFR we can calculate.
Yes, ma'am.
So here if we see this here, this HClR1, this we have written here, this initial whatever the HC concentration of the this here, HCl naught we have taken here. HCl initially taken into flask 25 ml. HCl received will sample कितना हो जाएगा आपका basically 25 minus 14, suppose it is 14.3, one value we are taking. Suppose if we are taking 3-4 value, then we will take the average value. We will put the average of that here. सो HCl रिएक्टेड विथ सैंपल कितना हो जाएगा आपका 25 माइनस 14.3. Is it okay?
Yes, ma'am.
Then we can here initial. What is the initial concentration in 20? Here we are taking in 25 ml. Okay. इनिशियल कंसंट्रेशन हमारा यहाँ पे क्या है HCl की. तो इनिशियल कंसंट्रेशन हमने ये निकाला है पर 1000 here. VHCl NHCl upon 1000. This is this gram mole. तो HCl not here we can find out here. Ca naught कितना हमारा है 0.1 gram mole NaOH per liter here. So this which is reacted HClR1 means which is reacted here we are taking. तो reacted हमारा कितना आ जाएगा इनिशियल कंसंट्रेशन हमारी कितनी है HCl की एंड आफ्टर रिएक्शन कितनी कंसंट्रेशन है वो माइनस कर रहे हैं हम यहाँ पर.
ओके मैम.
तो वो हमें मिल रही है कितनी यहाँ पे इतने ग्राम मोल इन सैंपल हम कितना ले रहे हैं 15 ml. 15 ml सैंपल में हमें इतना मिल रहा है. तो यहाँ पे कितना हमारा जो कंसंट्रेशन NaOH की रिएक्ट हो रही है दैट इज वी कैन फाइंड आउट. Conversion we can find out.
Yes, ma'am.
Conversion
Yes, ma'am.
Here 1 minus Ca1 upon Ca naught. Then conversion we can calculate. Now all of you are familiar with the kinetics of the CSTR here.
Yes,
ma'am.
Yeah. So this equation
ma'am.
of CSTR is equal to V upon Fa naught is equal to delta Xa over minus R. That we can here. So this we can find out C tau in terms of the tau. If we write Ca naught X conversion minus R. Ca naught Xa1 upon Ra1. Okay. So from here we find out here यहाँ पे आपका क्या है second order reaction we are taking. So for the second order reaction minus Ra is equal to K Ca naught square 1 minus X whole square. So this tau if we have written here the K1 or we can write here tau CSTR is equal to 1 upon K1 this in terms of the concentration in terms of the Ca in terms of the X conversion here. So here if we see in terms of the conversion here tau will be equal to basically proportional to that is Xa upon Ca naught 1 minus Xa whole square. This is for PFR. Similarly, this we have taken here the table. We have made the table here that flow rate. This we are यहाँ पे आपका होगा that is 10, and we are taking 10 10. Then we can take the 15. These three readings we can take at the 20. ये वैल्यूज हमने क्यों ली है क्योंकि हमने इनिशियल पे हमने स्टार्ट किया हुआ कि 20 से 45 ml पर मिनट और हम फ्लो रेट ले रहे हैं. तो 10 हमारा ये हो गया और 10 NaOH हो गया. टोटल फीड हमारा कितना हो गया 20, 30 एंड 40. So this is at t is equal to 0, t is equal to 5, t is equal to 10. So this we have taken at the 3 values here. We can take here is at average of these values, which we can put up into this calculation. Yeah. So now in the second table, similarly for the PFR, second table NaOH जो एवरेज वैल्यू हमारी यहाँ से आएगी सपोज CSTR से, that we will take here, put the average value of this here. HClR1, that here we have calculated here HClR1 from here. Then we can, when HClR1 is known, then we can calculate the Ca1. We can know the XA1 conversion, tau for CSTR for particular flow rate. Then we can calculate the R also we can calculate. Is it clear? Hello?
Yes, ma'am.
Similarly we do for the PFR here. PFR के लिए whatever the average value from the first table, this average of these, we can take 3, 4, 5 values, then we can take the average, but minimum 3 values that. So average reading of this here, HClR2 the same way, Ca2, XA2, then we can calculate these values here. So what is this kinetics of the PFR? This PFR में आपका क्या होता है? PFR में आपका क्या होगा? That is VI upon FA0.
is equal
You
to
can
0
write
to
tau
x
upon
integration.
CA0 is equal to, यहाँ पे हमारा क्या आ रहा है? X1 to X2, right? Then dx A upon minus R2, this here. So if we write in terms of the concentrations, so in terms of the concentrations क्या हो जाएगा आपका? Ca0 X1, this will also here change Ca1 to Ca2 and dCA over minus RA2 R2 here. Because here minus RA again, minus RA आपका we are considering as the second order reactions. So this will be the K Ca0 square 1 minus X whole square. This part we are taking as the second order reaction. So we can plot it here, suppose residence time versus आपका इनिशियल, अगर हम CSTR वाले में देखें तो CSTR वाले में आपका क्या था? Tau value we calculate, this XA value we find out here. So slope of the this. Here we can find out the slope here. So that slope will give the value of 1 upon, इक्वेशन क्या थी आपकी CSTR में, टाउ इज इक्वल टू XA ओवर CA0 के CA0
टाउ XA। मैम ऊपर भी CA0 था।
हाँ, तो ये कैंसिल हो जाएगा ना, यहाँ से हमने एक CA0 यहाँ से हटा दिया ना, ठीक है। तो बेसिकली हमारा क्या हो गया, XA upon 1 minus XA whole square versus this, the slope will give the 1 upon value of K, then we can establish a rate constant for this CSTR. Okay. PFR में हमारा क्या है, PFR that we consider here, and then here if we see for this CSTR followed by PFR, that minus 1 upon R versus X. Here it will be like this here. If we take in terms of the concentration, this will be like opposite this way here. So here we are taking in terms of the conversion X here. So this will be suppose the X1 value, this your X1, and this is your X2 here. So initial हमारा क्या है, पहले क्या लगा रहे हैं हम, CSTR, this value, this will be V1 upon F0 here. Then it is the, this is your for PFR here, V2 upon F0 here. So if we plot minus 1 upon, we can also plot minus 1 upon R versus X graph also. तो ये आपका पूरा कैलकुलेशन है, हाउ टू एस्टैब्लिश द रेट कांस्टेंट, दिस वी फॉर PFR, फॉर CSTR वी कैन फाइंड आउट हियर। इसको आप लोगों को यू हैव टू मेक मींस दिस प्रैक्टिकल कॉपी बनानी है आप लोगों को। हेलो,
यस मैम, ओके मैम।
प्रैक्टिकल कॉपी बनानी है, ये हम आपको भेज देंगे पावर पॉइंट वाली स्लाइड और कैलकुलेशन वाली स्लाइड, ठीक है।
ओके मैम। मैम एक्सपेरिमेंट्स वैसे नहीं होंगे?
एक्सपेरिमेंट कैसे हो पाएंगे, अभी शायद फर्स्ट ईयर के लिए तो ओपन नहीं है ना कॉलेज, इंस्टीट्यूट इज ओनली ओपन, इंस्टीट्यूट ओपन ओनली फॉर फाइनल ईयर, बीटेक फाइनल ईयर, एमटेक फाइनल ईयर, PhD थर्ड ईयर from 22nd February and not for all BTech final year. तो कैसे होगा? हेलो,
यस
यस
मैम।
मैम। मैम
आप जब इंस्टीट्यूट आएंगे, whenever you come to institute, then you will see that the setup and calculation, हमने इसीलिए पिक्चर उसमें आपका पूरा डाल दिया है, कैलकुलेशन कैसे करना, दिस इज बेसिकली क्या करेंगे वो हमने आपको बता दिया है। तो आप इसी तरीके से तैयार कर लीजिए उसका एम थ्योरी के बाद हमने उसमें काइनेटिक्स पार्ट थोड़ा सा पावर पॉइंट में नहीं पड़ा हुआ है आपका, ठीक है। तो आपको जो पेपर फाइल में लिखेंगे एम थ्योरी के बाद काइनेटिक्स में आप CSTR की काइनेटिक्स क्या है और PFR की क्या है, ये दोनों काइनेटिक्स थोड़ा सा देंगे, बुक से देख करके लिख लेंगे।
यस मैम।
ठीक है, इसके बाद प्रोसीजर, इसके बाद ऑब्जर्वेशन टेबल्स में आप एक रीडिंग का कैलकुलेशन दिखा दीजिए, ग्राफ तो प्लॉट नहीं हो पाएंगे क्योंकि 3-4 रीडिंग से रिक्वायर्ड है, या फिर हम आपको पूरा टेबल भेजें तब आप ग्राफ प्लॉट कर सकते हैं। तो ग्राफ आप जब एसपेन में सिमुलेशन करेंगे ना,
यस मैम,
तो आप उस समय ग्राफ प्लॉट कर लीजिएगा।
ओके मैम।
ठीक है, सेम थिंग एसपेन में आपका अगर सिमुलेशन हो जाएगा तो आप कुछ अलग अलग वैल्यूज फ्लो रेट चेंज करके और क्या वैल्यूज आ रही हैं वो टेबल मिल जाएगी। ठीक है, तो ये आपका इतना आपको एज ए एक्सपेरिमेंट तैयार करना है। अभी 11 बजे से आप लोगों का उसका होगा ना सॉफ्टवेयर का क्लास।
यस मैम।
तो ये हम बंद स्टॉप कर दें।
ओके मैम।
इसमें अगर आप लोगों को कोई प्रॉब्लम आती है तो आप लोग पूछ लीजिएगा बीच में, अगर कैलकुलेशंस वगैरह में। एक रीडिंग का तो एटलीस्ट कर लीजिए ना, फिर एसपेन में आप जब करेंगे तो उसका यहाँ रीडिंग फिट कर लीजिएगा। ठीक है। हाँ
हम किसी भी फ्लोर पे कर सकते हैं।
हाँ, जैसे हमने फ्लो रेट जो ले रहे हैं हम 20 to 45 जो हमारा टैंक का साइज है उस हिसाब से हम कितनी देर तक कर सकते हैं, कितना सैंपल निकाल सकते हैं, उस हिसाब से अगर हमने 20 to 45 सीसी पर मिनट लिया है, ठीक है, तो उसके बीच में हम कोई भी फ्लो रेट फीड फ्लो रेट कंसीडर कर सकते हैं। ठीक है,
ओके मैम।
तो 20 अगर हम ले रहे हैं तो 20 का मतलब हमारा 10 ये आ रहा है, इक्वल फ्लो रेट हम ले रहे हैं दोनों का, तो 10 इसका आ रहा है और 10 एथिल एसीटेट और 10 NaOH का, 20 हो जा रहा है आपका। ठीक है, इस तरह से, इसी तरह से आप अलग अलग फ्लो रेट्स पे आप निकाल सकते हैं।
ओके मैम।
और ट्यूसडे वाला आपका एमटेक का क्लास मोस्ट प्रोबेबली नहीं होगा क्योंकि हम आउट ऑफ स्टेशन रहेंगे ट्यूसडे वाले में। ठीक है,
ओके मैम।
वेडनेसडे आएगी।
ओके मैम।
ओके, लीव, यू मे लीव नाउ। जस्ट सेकंड है अभी आपका क्लास, तो उसमें आप
मैम थैंक यू मैम।
थैंक यू मैम।
थैंक मैम।
मैम